Hello everyone and welcome to AI Competitions. This is Gopi. I'm working as a data scientist in one of the fintech company called Karmalife.ai based in Bangalore. I started my data science journey when I was in BTech third year. Most of the things I learned from data science competitions and solving different types of problems in Kaggle. This is my Kaggle profile. I'm competition expert and notebook master. The main aim of this channel is to solve ongoing machine learning and data science competitions and provide you the base solution to start with, especially on platforms like Kaggle, Zindi, and Mission Hack. If you are into data and love good challenges, hit that subscribe button. Let's get started. Today we are going to solve one of the ongoing competition in Jindi. Jindi is one of the data science competition hosting platform. If you go to the compute tab, you can see the all ongoing competitions in Jindi. Today we are focusing on 5G energy consumption modeling. The main aim of this challenge is to predict the energy consumption of different 5G products. Okay, so they given some information regarding the data set, and we need to predict the energy consumption using some machine learning algorithms. Okay, we will see the data description, and if you see the evaluation, they are using mean absolute error to calculate the error metric. Okay, this is a regression problem, and each timestamp they given, we need to predict the energy consumption. Okay, interestingly, for this competition, they are using weighted mean absolute percentage error for the private leaderboard. Okay, so if you go to the price section, first place, they are providing 5k CHF. If you convert it into Indian rupees, it is around 4.5 lakhs. And also for first place, they are also providing the travel grant to Dubai to present their solutions. Okay, this is the brief overview of the competition. Okay, if you go to the data set, to download the data set, we have to go to this link, and you have to log into the account, and after login to the account, you go to data download session, and you can download all the data they given. About data, the data is divided into three data sets. One is the base station basic information. In this, they provide the base station name, and in each base station cell name they provided, and cell name provided, and what are the features. So RU type, mode, frequency, bandwidth, antennas, and TX power. In cell level data, they provided timestamp, base station, cell name, load, energy saving modes 1 to 6. Okay, so in energy consumption data, they provided timestamp and BS, and base station name and energy consumption by that particular base station in that particular time. So we'll go through data and we'll understand more while we are exploring the data. Once I downloaded the data, I uploaded into Google Drive. I created one folder called input, and I uploaded all the downloaded data into this input folder. To solve this problem, I'm using Google Colab. So to access your drive files in Google Colab, you have to mount your drive first. Then you can see the drive. Go to the My Drive, and where you are uploaded in Google Drive, you can see. I can see the input folder here. I uploaded into the input folder. Okay, first we'll import all the required Python packages. Then I loaded all the data set into Pandas data frame. You can see I loaded power consumption prediction.csv, cell level data.csv, base station information.csv, and energy consumption.csv, and sample submission.csv. Now we'll look into this energy consumption data. They provided timestamp, base station, energy. For each timestamp, for each base station, they provide the energy. Here energy is our target. For next, we'll look into the cell level data. There you can see they provided timestamp, base station, cell name, load, energy saving modes from 1 to 6. Now we'll look into base station data. Here they provided base station, cell name, RU type mode frequency bandwidth antennas TX power. Now we'll see the power consumption prediction. Here they provide the timestamp and base station. For each base station, energy is none because this is the test data they provided. Here W is the weight of that particular sample while calculating the mean absolute percentage error. Right? If you can see the W values, so here they're giving the more weight to some samples in test data. Now we'll go to the data processing. If you see, I rename all the column names into lowercase and standardize all the column names. Now we'll look into the Venn diagram. Here, the Venn diagram representing the train base stations and test base stations. The intersection between train and test are 921. Only base stations which are present in train are 2. Only base stations which are present in test are 97. Now here, I converted all the timestamp into pandas date time. Next, I merge the cell level data and base station data into one data frame. So we can see all the cell level data and base station level data in one data frame. Here you can observe that I filtered one base station. Okay, for each base station, for each timestamp, they provided multiple cell names. You can see cell name 0 and cell name 1 here. Here I group by base station and cell name and computing number of unique cell names in each base station. Okay, we see the base station 1 having the only one cell name, but base station 0 having the two cell names. So here we can clearly observe that each base station having the multiple cell names. Now I applied value counts on top of it. If you see, only one cell name base stations are 827, two cell name base stations are 191, four cell name base stations are 2. If you see the energy consumption data here, they provided energy consumption in base level. But if you observe our cell level data, we are having base level and cell level. So we need to convert our cell level data into the base level data. So here I am using pandas pivot function to convert all the base level cell level data into base level data. So here I assign the index as a time and base, then pivot column as a cell name. Then I assign all the required names after that. Now we can observe that we converted all the cell level data into the base level data. In this base level data, we are also having the cell level information. For antenna, we can observe the antennas. We have the cell 0, cell 1, cell 2, cell 3 information. If that cell is not present, then it's automatically filled with the none value. Here I described all the values. You can observe the described values for the each feature. Now we are merging energy consumption data, our target data, to the our cell level base level DF. Okay, you can see I merged the energy consumption data based on the time and base station and assigned to the DF. So this is the our final data frame. If you look into the energy, you can observe the some values are non values because those values are not present in train data. That value are present in test data. That's why they are not provided the energy column. So we need to predict for that values. Now coming to the EDA part, if you see the energy described, so minimum energy we have near to 0 and maximum energy we have 100. So they scaled energy in between 0 to 100. If you see the distribution of energy, it's something like skewed, right? So it is right skewed. So we can observe more values in between in the range of 10 to 40. In between we found the more distribution. If you go to the right, the skew is decreasing, right? So this is right skew. So now you can observe this plot. Here I plotted the line plot. X-axis is the our timestamp and the y-axis is the energy. For each timestamp, you can see how the energy is fluctuating. Here you can observe that they provide the around 7 days of data. You can observe here the less peak in night times, higher peak in the day times. Previously, we seen the overall energy for the each timestamp. Now we divided and hue by the RU type. Now we can see the each RU type how the energy consumption trend is going on. If you see RU type 1 having the higher energy consumption compared to others. Other types having the similar kind of energy, but you can clearly observe that some fluctuations also there in that. Next, we can observe that we plotted based on the mode type. Here we have two modes, mode 1 and mode 2, but mode 1 having only some section of data, but mode 2 having all the timestamps data. Now, here you can observe that energy based on the antennas and cell types. Here we can observe that while increasing the antennas, the energy consumption also increasing. You can see same behavior for the cell 1 antennas. Now we can see the bandwidth and cell types. Here you can see the bandwidth and cell 0. We can observe that while increasing the bandwidth, we can observe the energy also increasing. So here bandwidth 20 having the strong fluctuations. Cell type 1 also we are seeing the fluctuations, but cell type 2 and cell type 3 are the very less. Here I plotted the box plot for the each feature based on the energy. For RU type 1 having the higher energy compared to others. Based on the modes, you can see the mode 1 having the higher energy compared to mode 2. For bandwidth cell 0, if bandwidth is 20 having the higher energy values compared to others, then 10. Bandwidth cell 1, here also we can see all are close enough. For antennas cell 0, you can see antenna 4 having the higher energy. For antennas and cell 1, you can see the antenna 4 having the higher energy compared to other two antennas. Next, I plotted the categorical distribution in between train and test. Here you can observe the train and test count plots. If you see here, some categories only present in test data, but not present in train data. If you go to the mode, so this is the train data modes distribution. This is the test data modes distribution. You can see we have more modes compared to train data here in test data. So here you can observe for mode 1 we have more values in test data compared to train data. For bandwidth, you can observe that 8 is not present in train data, but it's present in test data. You can see the distributions here, train and test. Here the test data, we have the 8 bandwidth, but in training data, we don't have the 8 bandwidth. Same here, you can see the bandwidth cell 1. For cell 1, we have the different bands 2, 10, and 20. So those are looking fine. Now we can see the antennas also looking fine. For antenna cell 1, you can see the 8 is not present in train data, but 8 is present in the test data. Here I am doing group by split and RU type value counts sort by index. You can see type 11 and type 12 are present in test data, but those are very train data are very less. So we have to consider those cases while we are building the model. Now we can observe scatter plot between the load and energy. So while load is increasing, the energy also increasing. And here you can also observe the cell 0, cell 1, cell 2, cell 3 are the different colors. Here the cell 0 are having the higher, right? So cell one are having here and cell 3 2 are having here. Now I plotted scatter plot between Tx power and energy. Not much we can observe here. From the EDA we can conclude that there are some future values that are present in train data or not present in test data. There are some future values that are present in test data, those are not present in train data. So while building the model, we have to consider those factors and accordingly we have to build our model. Now we'll go to model building part. First I divided train data, test data based on the splits we created. Then I created future engineering function. It takes the train df, validation df, and test df. So first I created the hourly level futures. Next, I assign the splits to the each data frame. Then I concatenated train data, validation data, test data to create the encoding features. For base station, I created the BS encoder function. For categorical features, RU type, mode, and hour, I created one hot encodings using the pandas get dummies function. If you see here, I also tried some other features, target encoding and rolling features, and also rolling features based on the target. If you want to experiment with those, so you can explore different future engineering to improve your model. This is base solution. That's why I'm not complicating the model here. After feature creation, I divided train, validation, and test data. Here you can see target column as a energy and drop columns I mentioned as a time based base station split and target column. Here I am using k-fold cross validation as a our validation strategy. So here I am using number of cross validation splits as a 5. Then I created validation predictions as a np.zeros dummy values. Then I mention the test prediction list to assign the each fold test prediction to this list. Then I iterate over each fold. You can see I'm getting the train index and validation index. Based on the train index and validation index, I got the train df, validation df. Then I assign test data as a test df. After that, I pass train df, validation df, and test df to the future engineering function. There I am getting train futures, validation futures, and test futures. Here I am mentioning only the train columns. I am dropping the unnecessary columns from the training data. Then I separated into X train, Y train, X valid, Y valid, and X test. To solve this problem, I'm using light GBM regressor. So here is the training parameters I'm passing. First objective as a regressor and boosting type as a gradient boosting decision tree. Number of jobs -1, max depth as a -1, and metric I am passing as a mean absolute error competition metric. Number of boosting routes as a 10k. Then I pass the parameters to the light GBM regressor. Then I assign early stopping for callback and verbose callback. After that, I fit the model based on the X train, Y train, and validation sets. I passed as a X validation and Y validation, and also I passed the callbacks, early stopping callback, and the verbose callback to the model. Once the model fitting is done, I predicted the validation prediction and test predictions. After that, I calculate validation score as a mean absolute error. After that, I assign validation prediction to the fold validation predictions to calculate the out of fold mean absolute percentage error. After that, I append the test prediction to the test predictions list. Once your five-fold model is trained, I am calculating out of fold score based on the train data target value and the out of fold predictions. Here you can see I already trained the all five folds. So here we are getting cross validation CV as a 1.44. Here you can see test prediction list. We have all five-fold predictions here. Here I am taking mean of the test fold list. Here you can see test predictions means I taken the mean of the all five-fold test predictions. So if you see the shape of it,
it's matching with our test data shape. Here I assign test prediction mean as a energy column in test data. If you see the test energy distribution, it's following the similar distribution of train energy. Sample submission DF contain the time and base station ID joined with the underscore. So for test data, I created the ID future same as the sample submission file. So here I'm taking a time. I converted the panda state time into the string format. Then I joined base station and time using underscore. Now you can see we created ID future same as a sample submission DF and energy prediction from the model. Here I'm merging ID and prediction energy with the sample submission. So at the end we have ID and predicted energy from the model. Then I save it as a base model submission.csv. So here you can see then I downloaded that sample submit the base model submission. Once you downloaded your base model submission.csv, go to the competition website and click the submit button here. Then you choose your file and click the submit button. It will give the some public score. In my case, it's giving the 1.97. If you go to the leaderboard for 1.97, I got the 38th rank. To improve this model, you can try different feature engineering, or you can try different types of modeling and then ensembling. Some hyperparameter tuning also help to improve your model. Yeah, that's it from today's video. If you like the video, please subscribe to the channel